Welcome to the Shack of M1GEO. Recently on Twitter I see people talking about how they're measuring the UK mains frequency and correlating that with things that have happened on the power network. For example, load shedding and power stations going offline during storms, and how that affects the UK mains frequency, or any mains frequency for that matter. A lot of people are measuring the mains frequency, hobbyists that is, using simple Arduinos and just floating an I/O pin and using an interrupter to measure time against the CPU 16 meg clock frequency, for example, on an Arduino Nano. And I thought, I mean, it kind of works, but I thought I could do a bit better than that, and I had to think about how to do it and arrived at this, which is massively overcomplicated, but a reasonably reliable solution. And you can see here on this LCD module the current mains frequency as measured. And I'll talk you through the rest of it. But in order to make a measurement of time, you need something to measure, of course, which we're measuring the mains, and that comes in here. Not actually mains, this is going through a small 6-volt transformer with some filtering on it to remove any kind of higher frequency stuff. And it actually drives a wall clock, which is also synchronous to the mains, but I'm just taking a little sniff of it and using that through an optocoupler here, so to completely isolate this half of the circuit from this half. That signal is then being fed into an FPGA, which is over here, and all that's doing is counting a known good 10 megahertz reference, which comes in here. So these two signals here, they're taking a 10 meg reference from a Symmetricom GPS locked oscillator, which is a professional grade 10 megahertz frequency reference, and that's providing the FPGA with a known good 10 megahertz reference frequency, which having inquired on the through the Symmetricom Skippy interface, the thing is good and happy, so that's entirely happy that it's locked. So we know we've got a good 10 meg reference, and we're then measuring the mains frequency compared to that. What the FPGA is actually doing is it's basically running a frequency counter, counting this 10 megahertz, and every time the mains transitions kind of goes through a zero crossing, it resets the counter. And then all that's going on down here is that this Arduino is reading the counter over, these are the LSBs of the counter, and all that's happening is that the Arduino is reading that value out every main cycle and writing it to the screen, and also sending it over a USB cable back to the Shack computer. So that's all that's going on here. Just thought it was quite an interesting approach to see how the mains frequency changes. So the lowest I've seen this is 49.88 hertz, and then the highest I've seen it since I've been messing around in the last couple of hours is 50.08, so I guess around 1 hertz absolute difference I've seen. But yeah, I also had to play around with this circuit doing some other stuff, which is why there's another GPS module here, which was providing a pulse per second on this pin, which is no longer connected, and you can then make a frequency counter and count an unknown frequency here with reasonably high resolution, and a GPS 1 pulse per second, so you get a reasonably good frequency counter with that. And the FPGA has very big counter depth, so you can measure very high frequencies. Anyway, just thought it was a vaguely interesting little snippet. So yeah, I've leave the board running overnight, dumping data out over USB, and then see what I look at tomorrow, and also maybe see if I can compare it to anything online that's capturing the frequency. Thanks for watching, and hopefully you found it vaguely interesting. The code for the FPGA and the Arduino and everything else that's going on here is also on GitHub/M1GEO, and there's a project called Frequency Counter, and it's exactly the same code as that, just being used slightly different.